Hello, everyone. Welcome to Techie. So, you ask an AI a question. How does it actually get what you mean? I mean, really understand you. It's not magic, right? Well, it's a specific kind of tech that works like a long-term memory for AI. And today, we're going to break down exactly what that is and how it works. All right, so here's what we've got on deck. We're going to start with how AI even tries to find meaning in the first place. That'll lead us straight into what these vector databases actually are. Then, we'll get into the magic of similarity. That's the core of how they work. We'll also look at how they're powering the AI you're probably already using. And we'll finish up by checking out the current database landscape. Okay, first up, AI's search for meaning. To really get why this new tech is such a big deal, we first have to understand the old way of doing things, which was all about keywords. For the longest time, search was just about matching exact words. You can see it right here. You type blue car, you get blue car. That's it. Super rigid, super literal. But today's AI, it needs to go deeper. It has to understand what you mean, the whole idea behind your words. That's what we call semantic search. It's smart enough to know that Azure Automobile is basically the same concept as blue car. It's searching for meaning, not just words.
And that is the real challenge, right? Most of the data out there isn't nicely organized in spreadsheets. It's unstructured stuff. It's all the text on the internet, all the images, all the audio. It's messy. So the big question is, how do you teach a computer to understand the meaning of a photo or a podcast or a document?
Well, that brings us to the solution for AI memory. The answer to that huge challenge is a whole new kind of database, one that's built specifically to act like a long-term memory for AI. And yep, you guessed it, they're called vector databases. So how does this work? It all starts with something called vector embedding. Now, stick with me here. This is the process where an AI model takes, well, pretty much anything, a word, a sentence, a whole picture, and turns it into a list of numbers. We call that list a vector. But here's the crucial part. It's not a random string of numbers. It's actually a mathematical fingerprint that captures the meaning and the context of the original data. When you do this for a ton of data, you end up creating what's essentially a giant map of meaning. Just look at this diagram here. Things with similar meanings, like movie and actor, their vectors end up really close to each other on this map. And things that are totally unrelated, they're way, way far apart. So you're organizing information by how related things are, not just by what words they contain. I love this quote from AI Academy. It just nails it. It says, think of it this way. Traditional databases store exact data, but vector databases, they store the meaning of data. So a regular database knows the letters P-U-P-P-Y. A vector database understands the whole vibe of a puppy. That's why it knows that a dog having fun is a super similar concept. Okay, so we've got this incredible map of meaning. But how does an AI actually navigate it to find what it's looking for? Well, that brings us to the real magic of how it all works: similarity. The main trick here is called similarity search. It's pretty cool. When you ask the AI a question, your question also gets turned into a vector. Then, the database zips through that map of meaning to find the other vectors that are closest to your question's vector. These are its nearest neighbors. And that's how it finds the most relevant stuff, even if you didn't use the exact same words. Now, behind the scenes, there's a really important trade-off happening. If you want the search to be 100% perfect, what engineers call high recall, it's going to be a bit slower and cost more. But if you're okay with it being, say, 99% perfect, you can make it incredibly fast and cheap. And for most things, that's the sweet spot everyone aims for, getting almost perfect results in just a few milliseconds. So you might be wondering, how on earth do they search through billions of these vectors so fast? Well, they kind of cheat, but in a really smart way. Instead of looking at every single vector one by one, they use these special indexing algorithms. The most common one is called HNSW. The best way to think about it is like a highway system for your data. Instead of taking all the local roads, the index builds these express lanes and shortcuts, so the search can just jump to the right neighborhood of the map almost instantly and find a really, really good, though technically approximate answer in no time. All right, so that's the how. Now let's talk about the where. Where are these things actually being used? Because trust me, they're already powering a lot of modern AI applications. Okay, the number one most important application right now is something called Retrieval-Augmented Generation, or RAG for short. RAG is basically the secret sauce that makes today's chatbots feel so incredibly knowledgeable. It's the technology that lets a large language model, or LLM, pull in external information, stuff that's private or brand new, that it was never trained on. So how does RAG work? Let's walk through it. First, you take a bunch of data, say your company's documents, and you break it into small chunks. Then, you turn all those chunks into vector embeddings and store them in the vector database. Now, when a user asks a question, the system first does a similarity search to find the most relevant chunks of text from that database. Finally, it hands those chunks to the AI along with the original question. It's literally like giving the AI a cheat sheet or an open book test before it answers you. This diagram really pulls it all together. Over on the left, you've got the user's question. That question gets turned into a vector and sent off to the vector database. The database then pulls back the most relevant documents. That's the stuff in the green box. Now that context gets bundled up with the original question and sent over to the LLM. With all this extra info, the LLM can give a way more accurate context-aware answer, which you see there on the right. It's a beautiful system.
But RAG is just the beginning. This tech is everywhere. It's what powers the recommendation engines on Netflix or Shopify that know just what you want to see next. It's behind multimodal search, where you can, say, use a picture to find similar products. And it's even used in things like anomaly detection to find weird patterns in data that might signal fraud. Okay, so this tech is obviously super important, and a whole bunch of different tools and databases have popped up. So if you're a developer, how do you navigate the landscape and pick the right one for your project?
Generally, you've got two main paths you can take. On one hand, you have the purpose-built databases. Think of Pinecone, Milvus, or Qdrant. These are designed from scratch for one thing and one thing only: lightning-fast vector search, especially at huge scale. On the other hand, you have extensions for databases you might already be using. A super popular one is pgvector for Postgres. It just adds vector search on top of your existing setup. This table from Firecrawl is a really handy guide for making that choice. The takeaway is pretty clear. If you're already on PostgreSQL and have a reasonably sized project, something like pgvector is a great place to start. For new, smaller projects, maybe a managed service like Qdrant Cloud. But once you start getting into the tens or hundreds of millions of vectors, that's when you really need to look at the dedicated purpose-built options like Pinecone or Milvus. And make no mistake, this market is absolutely exploding. We're looking at a projected size of over $10.5 billion by 2032. That number alone tells you everything you need to know about how critical this technology is becoming for the entire future of AI. So, if there's just one thing you take away from all this, let it be this. Vector databases are the long-term, searchable memory for AI. This is the technology that lets AI move past just crunching numbers and actually start to understand the world based on meaning and relationships. You know, this whole shift from searching for words to searching for meaning, it just opens up a universe of new possibilities. And that leaves us with one final question for you. What will you build with an AI that can truly understand? We would genuinely love to hear your ideas down in the comments. And hey, if you found this breakdown useful, a quick like and subscribe would mean the world to us. Thanks so much for watching.